All right. So I wanted to take you through the visualizing fractions worksheet, just to make sure that we're all on the same page here. So first of all, number one asks us to locate 1/4 on the number line. So to do that, I would split 1 into 4 equal parts, and you can kind of eyeball this pretty well. So now each of these little things is worth 1/4. So this would be 1/4, 2/4, 3/4, and then 4/4 puts you on 1. So 1/4 would be right there, of course. Okay. So that's the number line model. The other model that we're going to use a lot is an area model. We're going to use rectangles. So you could draw a rectangular area model to represent 1/4, and there are a couple ways that you could draw this picture. One way that you could draw it would be to do that, and then shade in one of them. So this rectangle represents 1 unit, and you've split it into 4 parts, and you took one of them. Another way you could draw it would be to split it into 4 parts this way, and shade in one of them. So same idea, right? Either of those would be fine. 3/8 is kind of a similar idea. So we split the space between 0 and 1 into 8 parts. So half. So there's 4ths. And if I split the 4ths in half again, then I get 8ths. 1, 2, 3, 4, 5, 6, 7, 8. 8/8 would put you right on 1, which is where you want to be, right? So 1/8, 2/8, 3/8 is right there. Right, so there's 3/8. The rectangular area model, let's see. We could do maybe that, and then shade in 3 of them. It doesn't matter which 3, right? You could shade in this one, and this one. It's kind of random, but but there you go. That's 3/8. Okay. 7/4. Now this one is kind of interesting, right? Because the numerator is greater than the denominator. So the denominator here tells you how many parts to split your unit into, and then the numerator tells you how many of those parts you want to take. So if I split, so the denominator here being 4 tells me that I need to split my unit into 4 equal parts. But then 7/4 would be the 7th of those. And obviously, I get here, I have 1/4, 2/4, 3/4, 4/4. In order to get to 7/4, I need to also split the next unit into 4 equal parts. So then I have 1/4, 2/4, 3/4, 4/4, 5/4, 6/4, 7/4. Puts me right here, right? And this is where you get multiple representations for the same number, because on the one hand, you could say, well, actually, let me put it up here. So on the one hand, you could say we've got 1/4, 2, 3, 4/4, and then you could just keep going, 6, 7/4, and then at 2 you would be all the way to 8/4, right? So that's one way that you could label these numbers. But another way you could label them would be like this. You could say this is 1/4, 2/4, 3/4, and then 4/4 is 1. And that means 5/4 would be 1 and 1/4. 6/4 would be 1 and 2/4, 7/4 would be 1 and 3/4, and then 2 would just be, well, 2, right? But this is where you get to see things like, 7/4 is the same as 1 and 3/4, right? You get a similar kind of thing with a rectangular area model. That should say area. Right? So you're going to split your unit into 4 equal parts, but then you want to shade in 7 of them. Well, there aren't 7 parts to shade in, so you need a second unit, right? So you've got to give yourself a second unit and split it into 4 equal parts. Now you've got 8 parts in total, but you only want 7 of them, so you shade in 7 of these. And that would represent 7/4. Okay, couple more. So number 7 says, use the number line to show that 4/6 is the same as 2/3. Okay, there are lots of ways that you could do this. I'm going to do it by using different colors. So if I wanted to get 2/3 on there, that means I need to split, the 3 tells me that I need to split the space between 0 and 1 into 3 equal parts. So just kind of eyeballing it, it looks like it should be something like that. And so I could label this 1/3 and then 2/3, right? Puts me there. Now if I wanted to split that, if I wanted to mark 4/6 on there, I would need to split this into 6 equal parts. And so I could start off by splitting it into thirds, but then each of those thirds need to be split in half in order to give me 6 parts. Now I've got 1/6, 2/6, 3/6, 4/6, 5/6, and 6/6. I would land on 1 right where I want to be. So 1/6, 2/6, 3, 4. And I can stop there because my goal was to show that 4/6 equals 2/3. Well, obviously, right? It's just a different way of, it's just a different name for the same number, right? It's just a different name for the same quantity. To do this using an area model, you could draw something like this maybe. You could say, well, I'm going to give myself thirds and shade in 2 of them. So that represents 2/3. And to show that that's the same thing as 4/6, maybe what I could do is just draw a little dotted line. With the dotted line now, you've got this area split up into 6 equal parts, and you've shaded in 4 of them. So that 4 out of 6 is the same as 2 out of 3, right? So you could say without dotted line, we get 2/3. With the dotted line, we get 4/6. But clearly it's the same area, right? It's still the same area, and so those numbers must represent the same quantity. You might have drawn a little bit different picture, but that's kind of the idea there. And then number 9, I actually accidentally already kind of talked about when we looked at numbers, number 5 and 6 together. But let's go through it kind of quickly. So it says, use the number line to show that 11/6 equals 1 5/6. Okay, so 6, my denominator is 6. That means I need to split the space between 0 and 1 into 6 parts. So I can do that by doing thirds and then splitting those thirds in half, right? But I need to go to the 11th one of those. By the time I get to 1, I've only reached the 6th one. So that tells me I need to split the next unit into 6 parts as well. And by the way, here I did it by splitting it into thirds and then halves. You could do it by splitting it into halves and then thirds. That still will give you 6 equal parts. So then we can label these, right? So there's 1/6, 2/6, etc. 3, 4, 5, 6. So this is 6/6, 7, 8, 9, 10, 11/6, right? So if you're labeling it by 6 across the top, then you get to 11/6 there. On the other hand, you could say, well, this is 1. That means this is 1 and 1/6, 1 and 2/6, and so forth. So 2, 6, 3, 4, 5. This is 1 and 5/6 right there. So these two, that's just 2 different names for the same number. Okay. As for an area model to show that 11/6 equals 1 5/6, what did I even intend for you to do there? I'm not exactly sure. To show that 11/6 equals 1, well, maybe what you could do is this. So you know you're going to need at least 2 units to begin with. So 11/6 would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, right? So that's 11/6. On the other hand, you'll notice that this entire unit is shaded in. So you could just say this is just 1, and then this is 5/6. so that the total area is 1 plus 5/6, which is 1 5/6. So anyway, so when you count the individual little rectangles, you get 11/6. But when you realize that this entire unit is shaded in, that's just 1. And then this unit has 5 out of 6 parts shaded in, so that's 1 plus 5/6. But that shows that 11/6 and 1 5/6 are the same. So that's all I wanted to do there, is just kind of briefly walk you through that.